Hello, in this video we are going to look at the hydrocarbons, and we're also going to look at the nomenclature and structural formulae of the hydrocarbons, as well as the general formula of each of them. So the first one that we're going to look at, we are going to look at, as we said, it's the hydrocarbons. The first one that we're going to be looking at, we know that your hydrocarbons are made up of the following. I'm just going to maybe give you a tree diagram of this. Your hydrocarbons are made up of your alkanes, and then there is the alkene, and then there is another group that is called the alkynes. Right. So these are the hydrocarbons that we are going to be looking at. So these names here basically are giving us the homologue or the homologous series. So the homologous series that we're looking at is one, your alkanes, your alkene, and your alkynes. Right. So now, what differentiates or what distinguishes each one of these substances? Well, the first thing that you need to be aware of is that your alkanes have the following functional group. So I'm just next going to put the functional group. Remember, from the definition that we gave of a functional group, we said to you that a functional group would be the following: that this is a bond, an atom, a group of atoms that determines the physical and chemical properties of the organic compound. So in this case, we are just simply going to look at the functional group that's going to give us the characteristics of each of these different compounds. So the functional groups that are there for each of the hydrocarbons are as follows. Your alkanes have a carbon-carbon single bond. Your alkenes will have a carbon-carbon double bond in their structure somewhere, and your alkynes will have a carbon-carbon triple bond in their structure somewhere. Right. What do I mean by having a double, single, or simple bond in their structure somewhere? You need to remember that carbon is going to be tetravalent, meaning so it's going to form 4 bonds. So around each carbon atom, there needs to be 4 bonds maximum. So what you are going to say, okay, there is the carbon, and that carbon must just have simple bonds. There are no double bonds involved. And there must be a total of 4 bonds around each carbon atom. So here we've got 1, and then we've got 2, 3, 4. So this here will then have places for 4 atoms to bond with any of the carbons that are there. And in your alkenes, what are you going to have? You already have 2, so that means there's going to be space for another 2 more bonds. Whether it's up or at the bottom doesn't really matter. And then here there's 3 bonds already that have been taken up by the carbons. So then the rest is just going to be an extra bond to make it tetravalent. So it must be 4. Carbon exhibits tetravalency in all of the organic compounds that you are going to be studying. So when you look at this, you must always count 4, and at each point then there's going to be another atom that's going to bond, be it carbon or hydrogen. So if it's a hydrocarbon, so it's going to be either a carbon or hydrogen. No other element is going to be involved, right? So your hydrocarbons, we said these are homologous series, and in these homologous series, what you have, you've got different functional groups. That's what distinguishes them. The one, when your alkanes, you're going to have simple carbon-carbon bond, and then the other one you've got a double carbon-carbon double bond, and then the other one you will have a triple carbon-carbon bond. So this here is important, and in this case that's the important thing to look out for. So you're always looking out for that. All right, so that is the important thing about the distinction between the hydrocarbons. So the next thing that you need to remember, we said the prefixes are all the same for all of the organic molecule. So you just check the number of carbons, and then the prefix is going to be the same, which is the root name of the compound. And then the suffix is what's going to be different. So the suffix is the ending of the name when you're naming that substance. So the suffix, that is the ending of the name, is going to be distinct for each one of these. So your alkanes end with "ane." Your alkenes end with "ene," and then your alkynes end with "ine." So the prefix is going to be the same, but in the one it ends with "ane," alkenes with "ene," and then ines with "yne." Just have a look at that, have a look at that, and have a look at that. That's where you would get a cue for what the ending is going to be. So very important that you relate that to the different substances. Right. So then the next item that you would want to be aware of is the fact that the reaction of these substances, or the naming of these substances, is going to. So the naming of these substances is simple. What you need to look at is the number of carbons. With your alkanes, you can have a minimum of one carbon, and you can have as many carbons as you need. So the simplest of the alkanes is going to have one carbon, and that name and the formula is going to have a carbon, and then around each carbon there has to be 4 bonds, and each bond is occupied with a hydrogen. So now that gives you your methane. And then the next one will have 2 carbons. So you've got your 2 carbons, simple bond, right? And then the other 3 spaces to give you a total of 4 bonds are going to be occupied by your hydrogens. This here becomes the formula for ethane. Next one is a carbon chain with 3 carbons, and each of the carbon bonds are simple or single, and then around each carbon you need to have 4 bonds, and therefore you'd have 3 hydrogens, the fourth one being that bond that bonds to the carbon. Around the carbon number 2, the middle carbon, you already have 2 bonds, so you need one more that's going to be occupied by hydrogen, and the next one also occupied by hydrogen. In the last one you have 1 bond, so you need 3 more to make it have the 4 bonds on the carbon atom. So at the end of the day, when you look at this, you can now write the formula, the chemical formula of the substance. So you've got one carbon, right? So that you'll have one carbon, and how many hydrogens? One, two, three, four. So that'll be CH4. This here is the molecular formula. This here is the molecular formula. This, which I've represented, is the structural formula. So this is the structural, and this is the molecular. So that's the molecular formula. And then in this second compound, which is your ethane, it's got two carbons. So when you look at the number of carbons, you say, okay, fine, this is the structural formula. Around each carbon, you've got the three hydrogens, etc. And so what you can then write here is two carbons, C2, and then how many hydrogens? Count them: 1, 2, 3, 4, 5, 6, C2H6. So that is the molecular formula for your ethane. And then the next substance that you have is your propane. Again, count how many carbons do you have. You've got three carbons, so three carbons, so you write C3. And then how many hydrogens? You've got 1, 2, 3, 4, 5, 6, 7, 8, C3H8. So the molecular formula has got the C3H8. So you can go on and do for the other you can go on and write the molecular formula, structural formulae of the following, that is butane, pentane, and hexane. For practice, you can go ahead and do that, and then at the end I will give you the expected answers. There is also another formula that formula that you should be able to use to represent the bonding or the compound, and this is referred to as the condensed formula. So you've got your structural, you've got your molecular, and then you've got the condensed formula. Now, how do we represent the condensed? The condensed formula is just a matter of counting the number of carbons and then the number of hydrogens around each carbon. So in the first one, you'll have just your CH4. So that one doesn't change. But now when you look at the second one, in your ethane, you've got two carbons. So around each carbon, what you're going to have? You're going to have carbon. So it's going to be CH3 and then CH3. Around each carbon, we represent the number of hydrogens that are there. And then in the third one, we've got three carbons. So we've got CH3, the first carbon. And then the second carbon, we've got CH, how many hydrogens? 2, CH2. And then in the last carbon, we've got 3 hydrogens, so we've got CH3. So that is the condensed formula of the compound that we have represented. So go ahead and do the same also for the stated molecules that I asked you to represent, which are butane, ethane, pentane, and hexane. Now, we would also like to show you how you can actually name your alkenes and your alkynes. I'm just going to select this here and then reproduce it. Just create space. Right, so now we are also going to name these with your, in the naming of your alkenes, it is not possible for you to have an alkene with a single carbon. The reason being that you need to have a double carbon-carbon bond. So that it will not be possible for you to have an alkene with one carbon. So that the simplest of the alkenes is going to be ethene, which has got a double bond, a carbon-carbon double bond. So now we said that there are four bonds around each carbon. So that means those spaces are going to be occupied by a hydrogen. And then the next substance would be your propene. When we look at your propene, we have a carbon and then that. Around each carbon, again, make sure that you have four bonds. 1, 2, 3, 4. So there you'll have a hydrogen, another hydrogen. And then in this second carbon, if you count, you've got 1, 2, 3. So you can only have space for one more atom, which is going to be a hydrogen. And then in the last carbon, you are going to have three more bonds, and each one of those occupied by a hydrogen. So here when you name these compounds, you've got to look at the position of the functional group, which is the double bond in this case. Where is that carbon double bond? It's on carbon number 1. Now, with the naming, you always give the lowest number to the carbon that is closest to the functional group. So in this case, the functional group is our double bond. So the carbon that is attached to or that is closest to that is this carbon here. So this will receive a number 1, and that will be carbon number 2, and this will be carbon number 3. So where is the double bond attached? It's attached to carbon number 1. So that takes the name. So this here will then be called prop 1 ene. That one showing the position in which you find the double bond. All right. So let us look at the next compound, which is going to be the compound with 4 carbons, which is, so it's going to have 4 carbons. So we can have a situation whereby you've got that double bond on carbon number 1, and then 2, 3, 4 carbons. And so what we are going to have now, you start counting around each carbon, there must be 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then 1, 2, 3, 4 bonds. So at each one, make sure that you have your hydrogen. Right. So in this case, what do we have? We've got a total of 1, 2, 3, 4, 5, 6, 7, 8. So this becomes C4H8. And in this one, it was C3H6. If you count, you've got 2, 4, 6 hydrogens. So now, when we name this particular compound, we say we look for our functional group. Our functional group is a double bond, so we know it's an alkene. And where is that double bond? That double bond is attached to carbon number 1 and is between carbon number 1 and carbon number 2. Which is the lowest number? The lowest number is 1. So that would be carbon number 1, and that's going to be carbon number 2, carbon number 3, carbon number 4. So this is the longest continuous chain, telling us that this is a bute product, right? So it's going to be bute. Now, where is the double bond? The double bond is on carbon number 1. So we put a dash and then we name it as 1. And then what do we have? The ending in. What does this one show us? It shows us the position of the double bond. However, does that mean that the double bond must only be on carbon number 1? The answer is no. It is possible to have a situation whereby the double bond is not on carbon number 1 for that particular molecule. How? Well, the carbon-carbon double bond can be found. It could be even on between carbon number 2 and carbon number 3, and then you would have something like that. And then when you start counting the number of bonds around each carbon, you say, okay, there's 1, 2, 3, 4, 1, 2, 3, and then 4, and then 1, 2, 3, and then 4, and then 1, 2, 3, and then 4 for that last carbon. And then you say to yourself, okay, fine, you must allocate the numbers of the carbons such that the double bond must be attached to a carbon of lowest number. It doesn't matter where you count from, as long as the double bond is occupying a carbon with the lowest possible number. So if we count from the left and we say that's carbon number 1, this is carbon number 2, then that would be 3 and that would be 4. And so if you count, it's okay, this could be carbon number 2. Then someone says, but wait, what if I counted from the right going to the left? And if you decided to call this carbon number 1, and this carbon number 2, and that carbon number 3, and then carbon number 4, you will discover that the double bond is still on carbon number 2. So this would become your carbon number 2, and then your double bond would be on it. So it's important that you decide and you know which one is where you're counting from, so that your functional group is occupying the smallest or the least number possible of carbon, right? So in this case, it's on carbon number 2. So the naming would be but. Then you separate the position with a hyphen like that, but 2, and then another hyphen, and then ene, right? So that would be the name for that compound. Are these compounds the same? The answer is no. They are not the same. They will have the same molecular formula, right? They will have the same molecular formula. This is also going to be C4H8, and but they are different. They are different because of the positioning of the double bond. So because they are having a different position, they're going to have different chemical properties, right? And they're going to have different properties and different physical properties as well. So these are referred to as isomers. These are substances which have the same chemical formulae but different properties, and they are referred to as isomers, right? But we'll talk about isomers in the next lesson. So it's important that you are able to represent all of these compounds looking at the positioning of the functional group, right? So in the same vein, I would like you to give yourself some practice and then give us the structural formulae and molecular formulae of the following: your pent, right? Your pentene, whether and the different isomers that it will have, and then your hexene, and then your heptene. Right, we will continue with this series when we are in the next class. Thank you for watching. Please send us your comment, and share with amongst your friends.